Okay. Okay. Next, we want to discuss about the B tree. Okay. So, what is B tree? You can check it. What is a B tree? A B tree is a self-balancing tree. Okay. A tree having the self-balancing property, and we know what is self-balancing. Okay. Now, next, B tree is a generalized BST. Okay, it is a generalized binary search tree. Okay, why it is by generalized? Why it is generalized? Because it allows more than one. It allows more than one child. It allows more than one childs and more than one key. Okay, in a node. Okay, but it follows the BST property, binary search tree property. Okay, so it is called a generalized BST. Okay, okay, that is why it's called a generalized BST. Okay, okay. Next, we are going to discuss the properties of B tree. Okay, what are the properties of B tree? So let us go to an example of B tree. Okay, let us first go to an example of B tree. This is an example of B tree. Okay, there would be a root node. There will be a root node, internal nodes, and leaf node. Okay, these are the leaf nodes. And now, just to go through it, this is an example. Okay, B tree. Okay, next, what are the properties of B tree? So, the properties of B tree. Now we want to discuss the properties of B tree. Okay, so if you consider uh, properties of B tree, every node has a maximum m children. Usually, a B tree is defined by its order. Okay, B tree is usually defined by its order. Okay, order is basically the maximum number of children allowed in a node. Okay, maximum number of children is called order. Okay, so every node has maximum m children. Okay, so uh, every node has the maximum m children. That is the order of the B tree. Similarly, the minimum number of nodes. So if you consider the leaf node, uh, the minimum number of nodes is 0, and that is the minimum number of nodes means child nodes. Okay, the minimum number of child nodes. Okay, minimum number of child nodes. Okay, minimum number of child nodes. So how many childs a node in the B tree can have? So minimum number of child nodes. What is the minimum number of child nodes? Okay, so for a leaf node, minimum number of child node is 0. Okay, next, what is a root node? A root node should have 2 child node. Okay, a root should have 2 child node. Then what about the internal node? What about the internal nodes? Then m by 2 child nodes is necessary, and it is, we used a function c. Okay, for example, what is c? For example, suppose m is 7 by 2 is equal to 3.5. Okay, so we should, after applying the ceil function, it will be 4. Okay, so in this way, the seal function is used. Okay, so seal. Next, every node has maximum m minus 1 keys. Okay, every node has maximum m minus 1 keys. Okay, so then minimum number of keys in the root node should be 1. Okay, minimum number of keys in a node. Okay, just note it, because usually if you consider a node, then it will have more than one nodes, more than one keys. Okay, just note that point. Usually if you consider B tree, a node have more than one keys. Okay, more than one keys, 1, 2, 3, in this way, and different number of keys. And this property saying that every node has maximum m minus 1 key. So m is the order of the key, order of the B tree. If m is equal to 5, suppose m equal to 5, the order of the tree is 5, then how many uh, keys allowed in a node? It is 4. Okay, maximum 4 keys are allowed in a node. Similarly, minimum number of keys. So the root node should have one key. Okay, it means keys. Okay, this is keys, and this is nodes. Okay, this is nodes case, and this is keys case. Okay, so uh, how many root nodes should have one key? All other nodes should have minimum m by 2 minus 1, and m by 2 is seal function, sealed with sealed. Okay, then all leaf nodes should be at the same level. That is another property. Okay, all the leaf nodes should be at the same level. Next, another property is all keys of a node are in sorted order. All keys of a node are in sorted order. Okay, if you consider a tree, like suppose this is a node, there are two keys, 6, 7, and it is in the sorted order. Okay, these are the various properties. Additionally, it should satisfy the BST property. For example, if you consider what is why it's a generalization of BST. It's a generalization of BST because if you consider this, then if you consider this node, the left and particular key, if you consider this node and the particular key 5, then the left child should have keys less than 5, and right node should have keys greater than 5. So it satisfies the BST property. So these are the properties of B tree. Okay, next we are going to discuss insertion operation can be performed. Okay.